Okay, kinematics. This is chapter 20b. Let's just jump right in. I'm assuming that you're looking at old IB questions. Please tell me if you do not have access to the old IB questions. Please let me know at this point. So what is kinematics? Kinematics, for those of you taking physics, you need to know this. It's the study of movement. Movement. And so the idea is we're going to connect position, velocity, and acceleration. First, it's where am I? The second is what's the rate that I'm changing, and that's velocity. And the acceleration is what is the change of my change? So like when you're stepping on the pedal, like you're speeding up, but then you're speeding up faster. Okay, so the letter we're going to use S, or S of t, is for position. You're going to be given a function, and you're going to say, what is my position at time t? 1 or t, or this position. You're going to plug it in, and that's going to tell you where you are, or how far away you are at a specific time from the origin. The position from the origin. Now, obviously, there might be positive numbers and negative numbers. That's just a direction. The next thing is velocity. So the derivative of the change of how you're changing, that's v of t. That's known as velocity. And that's the rate of change of displacement. And you know that when you're sitting in a car, 80 kilometers per hour, that's your change. The first question is, where am I? I'm 500 miles away. Oh, well, if I've been traveling for 10 hours, what was my velocity? Oh, 50 kilometers per hour. And then the last thing is acceleration. That's the second derivative of this position, which is the first derivative of velocity, and that's acceleration. And that's the rate of change of velocity. Just for fun, jerk is the derivative of acceleration, or the third derivative of displacement is called jerk. And then the fourth is snapple, and the fifth, then the sixth is pop. Jerk, snapple, pop. Anyway, that's not important. So once again, this is a math class. It's not physics, it's math. So we're just dealing with it's in the calculus unit. So if the derivative takes us this way, the integrals take us the other way. So the integral of acceleration is velocity. You're going to have that C. You need to deal with it. And the integral of velocity is displacement. You're also going to have a C. There's a question where you're taking the integral twice, and you're going to have two C's. That's just an algebra problem, systems of equation. Don't get the science in your head. Just be like, oh, this is a math problem. Okay, what's the next thing we want to talk about? Well, the next thing we want to talk about is speed. Speed, how fast we're going. We know from vectors is that velocity is a vector. It has magnitude and direction. Speed is a scalar, and so it's just the absolute value of velocity. I just want to know how fast you're going. I don't care where you're going. And once again, it's the magnitude of the velocity. Magnitude of the velocity. Let's just say it again and again. This is a math class. It's not a science class, so don't get caught up in that. So the next thing we want to talk about is uh, displacement versus distance. So you have a graph. Um, you want to know like how far in total you move. So we know. So we have velocity. So I'm sorry, with the velocity function, um, the integral of VST tells us the displacement. Because if you think about it, the integral of velocity is the position of the origin. So you're constantly adding up your distances from the origin, right? So you can say, you know what, in total, it can tell your distance or your displacement. Now, I'm going to write the other thing. It's the integral of the absolute value, and that tells you the distance. Sorry about that. So the integral of velocity tells you the displacement. The integral of the absolute value of the velocity gives you the distance. Why do we need the two formulas? Well, let's take a look at the graph of sine of x. Let's say that v of t, can you see that over there? Yeah, let's let the velocity be the sine wave. Let's let the velocity be the sine wave. Let's take a look at this graph. Now, we're looking at the distances, right? And so we see there's all these displacements. But what happens here is that when we add these all up, we get 0. And so that tells us our displacement. And with displacement, we have the problem that, we're canceling everything out. For example, I stand here, close your eyes. Does it look like I moved or not? And you would say, no, Mr. Eilert, you didn't move at all. So my displacement is 0. But the next question might be, for those who kept your eyes open, did I move at all? And you say, yeah, you walked in a circle, Mr. Adler. Like the sine wave, you walked in a circle. So we need to be able to distinguish between the two. So be very careful. If you're asked for the displacement, you take the integral of the velocity. If you're asked for the distance, you take the integral of the absolute value of the velocity. This is probably going to be a part 2 question. Use your calculator. And that's the idea. You're going to work on problems in the book. These are it's more just applications of integration. And then these questions, you're just looking for key words. Once again, it's a math class, it's not a science class. So when you see the word initial speed, you say, oh, you know what? That's the absolute value of the velocity at 0. What's another word? Body comes to rest. Body comes to rest. Well, that's when the velocity is 0, equals 0. Another thing, maximum displacement. Well, if the displacement is s, and we hear the word maximum, we say, oh, take the first derivative, set it equal to 0. Well, it's the same. Why are these things the same? Well, let's think about this. If there's a maximum displacement, this is as far as it goes before it kind of like turns around. And same idea. And from a science point of view, we're not science. I don't know what I'm talking about. I think the idea is if like you throw a ball in the air, the moment that it changes direction, it's not moving. So the velocity is 0. But that's the idea. Body comes to rest, velocity equals 0. Maximum displacement, velocity equals 0. So it's like changing direction. It's like changing direction. Like changing direction. What are some other important words? Maximum speed. once again, that's also the second derivative. That's also, the second derivative, or the first, or take the maximum speed. Take the derivative of velocity and set it equal to 0, but remember, please remember, because it's speed and it's the absolute value, if you get like 1 or 2 t, you're probably going to get 2 t values. When you plug it back into the velocity, you have to take the larger value of the absolute. So what did I say here? Remember, determine the max of, the absolute value of these times. Or if they start with speed and stuff, just remember, you know what? Just find the maximum of the graph on your calculator. Right? So let's say I have the velocity here. Well, let's go back here to the sine wave. Where is the maximum of the sine wave? It's here. Like, it's there. You can see it. Whereas, the maximum speed, well, you'd have to determine between these two values, which one of these, when plugged back into the velocity, when you plug it back into the velocity and take the absolute value, one of those values is going to be the maximum speed. So once again, to find the maximum, either take the first derivative and set it equal to 0, or take the first derivative and set it equal to 0, or just literally look at the graph and be like, oh, there's the max. Oh, there's the min. I think that's all the code words. What else? Let's see. Oh, just remember, these are just algebra problems. So go through the problems in the book and go through the old IB questions. Please ask me if you can find the old IB questions. So I think I'm talking pretty fast, but you can slow me down. There's a topic that was omitted from the curriculum this year. And so I want to talk about this topic because you might be seeing it in the IB questions. You may be like, Mr. Adler, why didn't you go over this? So I'm going to go over it now. You're not responsible for it. The idea is that the omitted topic is the idea of acceleration as a function of displacement. Acceleration as a function of displacement. Once again, I've been telling you, things are a function of time. But this unit, which they took out, I think so, I read the curriculum that way, but I'll show you anyway, is they're manipulating it so that acceleration is a function of time, of displacement. Let's go through the math. So we know, here's the math. I'll say it again, this is not a science class. We're mathematicians, so we're just manipulating things. So we know that acceleration is the derivative of velocity with respect to time, correct? Well, I technically could multiply this by 1, right? And I do technically know that 1 is the derivative of s with respect to s, right? In the same way, if we took what is the derivative of x? It's 1. So I can say the derivative of s with respect to x is also 1. Well, mathematically, I can manipulate my fractions. I can manipulate my denominators in the same way that I can say 2 over 3 times 4 over 5 is equal to 2 over 5 times 4 over 3, right? I can say this. Oh, sorry. In the same way I can manipulate this, I can manipulate my differentials, right? So I'm going to write that, ds dt times dv over ds. And therefore, I have the formula velocity times dv over ds. And therefore, we see that, good, we have this formula. This is, and you got it's in the old formula book. It's not in the new one. So what's going on here? Well, you'll see from the old AB questions is that you're given velocity as a function of displacement, and you're asked to find the acceleration. You're asked to find acceleration as a function of displacement, and you can see from the formula here, you take the first derivative with respect to s, and then you leave the formula, and you have acceleration as a function of displacement. It's not on the new IB exam, but I just want you to see exactly what the math is going on behind here. And that's basically it, so work on 20B. Please ask any questions.